Hi everyone. Motion in a plane we are going to discuss. In this motion in a plane, the most important topic which we need to discuss here, the most important topic is that motion in a plane is projectile motion I am going to discuss. Projectile motion. What do you mean by projectile motion? I hope this is visible for everyone. What do you mean by projectile motion? When an object thrown into the space from a ground or a tower under the influence of acceleration due to gravity, under the influence of acceleration due to gravity is called as projectile motion. Here some conditions are applicable. What are those conditions? This is we say projectile motion. When you are throwing an object, you should follow the angle must not be in 90 degrees or 0 or 180 degrees. Therefore, the object other than 90, 0 or 180 degrees, if it is making an angle theta with the horizontal axis or with the horizontal axis, then such type of motion we can call it as projectile motion. Simple. Any object is said to be a projectile in the sense object must travel under the influence of gravity in the angle other than 90 or 0 or 180 degrees. Okay? This is we call as projectile motion. Next, you can see the diagram here. The object which I have thrown in this direction, it has traveled like this and falling on the same ground where I am thrown. Okay? But at certain distance it is falling. Right? So, simple examples. What are the examples? Most of the people you know, a boy throwing a stone to reach longer distance, and cricketer throwing a ball in field, or if you are using a pressurized water pipe in this direction, so the water automatically through the pipe, the water will go and fall like this, right? This is all we can consider as projectile motion. Now, this is the person is throwing from ground. The object is moving other than 0, 90 or 180 degrees under the influence of acceleration due to gravity. We know that in kinematics, without cause, we are studying the motion. But here, only nature force will act. What is the nature force? Acceleration due to gravity is a nature force, right? Now, you can also see that how many types of projectiles are there. Say a cricketer throwing a ball. Okay, if I am throwing this pen like this, I am trying to allow to go this maximum distance in the sense have to use between 90 and 0 degrees, right? Between 90 and 0, who is there? 45 degrees, right? So, such type of motions are called as projectile motions, or that particular object is called as projectile. What we say is projectile. Got it? Now, you can also see here types of projectiles. Then we will enter into the what is exactly projectile motion. Types of projectiles. We have different types of projectile motions. They are whatever till now we have discussed. When an object is thrown from the ground, such type of projectile is called as oblique projectile. oblique projectile. If an object is thrown from certain height, it is called as horizontal projectile. Horizontal projectile. And we have, these are the two main. Apart from that, we know inclined projectile on the staircase or inclined plane. Inclined projectile. Right. Let us see how the picturization of these projectiles. When we are throwing from the ground, the projectile motion with respect to x-axis and y-axis from the ground, if you are seeing, this is a projectile motion we can find. Okay, this is, we say it is as an oblique projection. Now, what do you mean by horizontal projection? Horizontal projectile means if an object is thrown from a building, or from a tower, then such type of motion is called as horizontal projectile. Not only this, for example, an aeroplane is moving. Okay, when an aeroplane is moving, it releases a bomb. It releases a bomb. The released bomb, how it comes back? Usually, it comes back like this, and will fall. Right? So this also we call as at certain height, so horizontal projectile. Or in any floods will come and all, in that situations from the helicopter, people will throw the food packets. Okay, so our rescue team comes and catch the people, and somebody will come down. Means the plane or helicopter is moving in this direction, it releases the object in this direction or bomb. Therefore, since it is moving in the direction from certain height, it is falling in a form of projectile motion. Okay. Now, inclined projection. What does it mean, inclined projection? If any object is thrown from a staircase, let us say these are the steps. This is a staircase, right? Now I'm standing here, and a boy standing here and throwing a ball, right? Ball will fall here, from there it can fall here. So this type of projectile is called as inclined projectile. This is also, I can represent an inclined plane like this. When somebody is standing and throwing a ball from here to here, right? So this is nothing but inclined projection. Here angle may be theta. If you stay here, also angle may be theta with the horizontal axis. Means this is the inclined angle. Okay, means whatever you are throwing the object, the projectile angle with respect to inclined angle, there may be changes. Right? So these are the basic projectile motions in the two-dimensional motion. But as per our curriculum, if you go for the JEE mains and all, we will go further projectile motions in numerical based. But for us, for the board, we need to discuss about oblique projection detail. When you discuss this is from the ground. Okay, if you understood this, then automatically you can apply in these two cases also. So try to understand oblique projection, how it is. So since it takes more area of the board, what I am writing here, projectile motion, projectile motion. That too oblique projection we are discussing. Let us say first, here I am going to derive the path of the projectile or the trajectory of projectile as a parabola. Means, how do I know that is a parabola? In the sense that shape is in terms of parabola. Let us say this is origin, this is along x-axis, y-axis. I am considering the border axis to show the two dimensions. Now, I have thrown an object with certain velocity. Then object has moved like this. So the velocity vector I am taking here like a u, which is making an angle theta here. Right? Since it is making an angle theta, this is the velocity vector. The object has traveled like this along x-axis. Now, from this diagram, I am trying to prove how the object has traveled along the path. So, I need to find the motion of an object. In the sense, I should consider one point. Here, I am considering a point P of x comma y. Along x-axis, y-axis, I am going to describe. At any instant, you can consider the point P, no problem. So, after consideration, I am drawing a normal because this is a velocity vector, entire projectile motion, which is a curved path. So, at any instant, you wanted to find the velocity vector. In the sense, if you draw the normal, then we can find the direction of projectile. So, this is the velocity vector u. Along horizontal direction us, along vertical direction it is u1. This is also, since it is tangent, is making an angle theta in the horizontal axis. Since I have considered the point P, let us consider P point P of x comma y. Now I am going to describe the motion of this particle. At this instant, at this position I have considered, with respect to that point P, I am going to find the position of that point, okay, along the x-axis. Because since it is a two-dimensional motion, in the sense, I have to describe the motion of an object along x-axis as well as along y-axis. Okay. So first of all, individually from along x-axis, I am going to discuss. Along x-axis. First, I want to determine the position of the particle. Position or displacement, position of particle. To find the position of any particle which is in the motion, we have to use equations of motion. Which equation of motion going to give us position of the particle? That is from second equation of motion. Second equation of motion. What is that? S equal to ut plus half at square. This everyone knows from 9th standard. So S stands for along x-axis position x. So I am taking here x. Okay. Now, before describing this, I have forgot to tell you the most important considerations in the projectile motion. See, you make a box here, considerations, or I can say conditions. What are those conditions in projectile motion? Any object is said to be projectile in the sense, what are those conditions? First, object is traveling under the influence of gravity, we know. A resistance is negligible. Neglected. First one. Second thing is that along the horizontal direction, velocity is constant. So acceleration is 0. Along x-axis horizontal direction in projectile motion, velocity constant. So acceleration ax equal to 0. Along vertical axis means along y-axis. Along y-axis, acceleration due to gravity changes. Therefore, Ay equal to minus g. Okay. Though object is coming down, since it is we are discussing two dimension, with respect to negative y-axis, the displacement we considered. So my energy has taken here. Okay. Otherwise, people will have the confusion in this case. While it is coming towards the ground positive, no sir. Yes, but with respect to this displacement of a projectile motion, here we are taking along vertical axis negative. Means along vertical axis, acceleration is changing here. We are showing that. Okay. Now let us come into back along position. So u into t. U stands for, this is along x-axis here. Okay. Ux, this is indicating magnitude of velocity vector along the horizontal direction. Ux equal to u cos theta. Why I can write that, if I consider this is as a right angle triangle. So adjacent side gives the cos component, opposite side gives the sine component, right? So these two are parallel, so that's why vertical component uy can be considered as u sine theta. Right now? So ux equal to u cos theta, uy equal to u sine theta. Now, same with respect to the considerations, here ux stands for u cos theta and time. Time is remains time only. How much time does it taken? At what time? At a particular instant of time, the position of the particle we are finding. So time t and y. This part, since this is ax along x-axis, this part is zero because acceleration is zero. So total term will become zero. So now I have the position of the particle along the x-axis in projectile motion is this. Okay. Now, what is the velocity along x-axis? And that is ux equal to u cos theta. That we know. And vertical axis uy equal to sin theta we know. Now, I wanted to find time. Time t equal to, I can write x by u cos theta. X by u cos theta. This gives the time of a instantaneous time or time which taken for this point to travel. This is along x-axis. Now, next, I am going to find along y-axis. Along y-axis. Whenever I am going to take along y-axis, what I wanted to take here? Along y-axis again, I wanted to find the position first. Position of particle. So, same second equation of motion. From second equation of motion, S equal to ut plus half at square. S equal to ut plus half at square. We know S stands for along the vertical axis is y. And u stands for, already I told you, uy equal to u sine theta. Tan is t as usual. Now, instead of writing plus, since I have ay equal to, we know, minus g. In the projectile motion we have considered. So, minus in the place of ay, g, t square, half as usual. This is a displacement of a particle along vertical axis. This is the displacement of the particle along x-axis. Right? Let us take, this is equation 1, this is equation 2, this is equation 3. Right? Now, if I wanted to, this is along x-axis, y-axis, separately I found. But I wanted to know the path of the projectile or the motion of the particle combinedly. Combinedly in the sense, in 2 dimension I want. I need to combine x-axis and y-axis. How it is? there should be one link between these two equations. What is that link? Time factor. Time is common for both cases. Time is common for both cases. Both cases in the sense, along x-axis, along y-axis, the particle is one only, right? But we are with the origin of x-axis, we have found the displacement. With the origin of y-axis, we found the displacement, right? But our aim is to find that the path of a projectile. So I need to find combinedly with respect to two dimension. For that purpose, a small change I'm going to do. The small change is that equation 2 is substituting in equation 3. Means this time I'm substituting in this. Now, what will be the change? See, y equal to u sin theta tan t, x by u cos theta, x by u cos theta minus half g t square. So x square by u square cos square theta. This is actually total path of a projectile. See, after simplifying the view, I'll give a proper symmetrical equation after simplifying. U cancel. So this I can write x into sin theta by cos theta gives us tan theta. Right? Is it visible now? Next, minus, this is g by u square cos square theta. I'm keeping in the bracket, x square I'm writing separate outside. Now here x square. Means x and x square are the variables. It shows from this equation. This is a standard equation of a parabolic path of projectile. How sir? I'll show you. This part of A, this tan theta I'm taking as A. This tan theta taking as A, and this total part I'm taking as capital B. So that equation I can write as y equal to A into x minus b into x square. Variables are remain same, the constant values a and b which are equal to this, where a equal to tan theta, b equal to g by u square cos square theta. So this is a standard form of parabolic path or parabolic shape. Y equal to x minus bx square or ax plus bx square if this curve is opposite way. Okay, this is a symmetrical form. We have symmetrical form of straight line linear equation, same like circle equation, ellipse equation, same like parabolic equation we are having. That is y equal to x minus bx square. Therefore, mathematically I have proved that path of a projectile is in a form of parabolic path, in the shape of parabolic. So, question can be asked, find the trajectory of a projectile. What is that? This is the trajectory of projectile. Okay, they'll ask, prove the trajectory of a projectile as a parabola. That is this. Okay, this is all about the clear-cut projectile motion. Now, further if you go, there are so many things are there: time of flight, maximum height, horizontal range, and velocity at different instant and different heights of projectile. We will discuss in the next class. Okay, so this is anywhere you can draw the tangent. Remember, here also I can draw tangent like this. Means this is ux, this is u1, this is u. Here also I can draw. Right? Everywhere you will have, at any instant you can draw the tangent. Means, from this what you understood, I'm drawing tangent in the sense, the direction of the velocity of a projectile is tangent or tangential. So if you wanted to discuss that is in a form of equation oriented, we'll see in the next class. Okay, thank you very much.